Today's lesson is lesson 3.3.3. This is a lesson on properties, which you're going to be writing on page 17 of your toolkit. So we're talking about properties, and these will be on the test, definitely. So they start with problem number 112 in the book. It says Juno's working on a problem, 24 plus 3 plus -4 plus 7, and exclaimed, I know, it must be 30, because 20 plus 10 is 30. So let's investigate this a little bit. You got 24 plus 3 plus -4 plus 7. And Juno said, I know that it is equal to 30, because 20 plus 10 is 30. So the question is, do you see it? So when you're looking at the numbers, how they're all being added together, so we know that we can add them in any order. So I can take the 24 and the -4, and those together make 20. So I'm just moving this plus -4 next to the 24, and then the 3 becomes next to the 7, plus 3 plus 7. Okay, so addition can go in either order. So that gives me 24 plus -4 is 20, and 3 plus 7 is 10. Okay, so using the order of operations, I'm just going left to right, but Juno happened to group these two together, which is a different property. So this is equal to 30. Now, we're getting into what's called the commutative property. You might be familiar with the commutative property of addition. So let's investigate that a little bit. Commutative property of addition, just put that in parentheses. Now in the commutative property of addition, it's kind of exemplified here is, doesn't matter which order we add numbers. 10 plus 3 is 13, 3 plus 10 is 13. So it doesn't matter which order, it's always going to give us the same result. So the commutative property, when we're adding, allows the order to change. And the way I like to think of it a lot is the word commute means to travel from one place to another. If you're a commuter, that means you live at home and you travel to work, or you travel to school. You're a commuter. You have commuter traffic. So to commute means to move. So the order changes, the order moves. Okay, to move or to travel. All right, so which properties are commutative? Let's look at addition first. So we're going to have the simple problem of 3 plus 7. Now, does that equal the same result if I switch the order, 7 plus 3? And the answer is yes, because 3 plus 7 is 10, and 7 plus 3 is 10. Right, so that is a big yes. And let's see if subtraction, is that commutative? So we're going to do 3 minus 7, and then we're going to change the order and do 7 minus 3. Are those two equal? And let's see. So 3 minus 7 is -4. And does it equal 7 minus 3, which is 4? All right, so the answer is no, that is not commutative. So we talk about multiplication. Let's do same numbers. 3 times 7. Let's change the order. 7 times 3. Are those equal? 3 times 7 is 21. 7 times 3 is 21. So yes, those are commutative. Is division commutative? Let's do 1. Is 1 divided by 2 the same as 2 divided by 1? All right, so 1 divided by 2 is 1/2, and 2 divided by 1 is 2. So we just flip the order, and we see that it did not give us an equation. All right, so that follows that the two properties that are commutative are addition and multiplication. Those two are commutative. Now the associative property, this is another property that Juno used up here. Associative property is, now just like commutative, I took commute, means to move or to travel, the order changes. So it's associative property, the root word of that would be to associate. And what does it mean to associate? Usually who do you associate with? Your group of friends, right? So this is a group. Okay, groups associate with each other. So in associative property, that allows only grouping to change. Only grouping changes. All right. Okay, so let's look at which of these is, which of these properties are associative. So we know that only the grouping changes. Now, only means the order does not change. So that's very important. The order does not change. And that means that the numbers are not going to move around at all, only the order in which we do it. So up here we see that Juno did 24 plus 4 as a group once he moved them, and then 3 plus 7 as a group once he moved them. Okay, and that's how he saw the 10, that's how he saw the 24. So we can pretty much say that that's what he did right there, just kind of grouped them. Okay, so let's look at a couple of problems here. Let's look at is addition apply to the associative property? Does associative property apply to addition? 5 plus 4 plus 2. When I group the 5 and the 4, is that equal to 5 plus 4 plus 2 when I group the 4 and the 2? So remember, the grouping symbol means I'm going to do that first. So 5 plus 4 is 9, plus 2 is 11, and 4 plus 2 is 6, 5 plus 6 is 11. Okay, so yes, that is associative. What about subtraction? Okay, so we have 5 minus 4 minus 2, where I'm grouping the 5 minus 4, and then 5 minus 4 minus 2, notice same order, where I'm grouping the 4 and the 4 minus 2. So let's see, 5 minus 4 is 1, 1 minus 2 is negative 1. 4 minus 2 is 2, 5 minus 2 is 3. So that is a no. Associative property does not apply to subtraction. Multiplication, let's try this. So we have 5 times 4 times 2, where I'm grouping the 5 times 4. 5 times 4 times 2, where I'm grouping 4 times 2. That will give me 20 times 2, which is 40. And this will give me 8. 5 times 8, which is 40. Does apply to multiplication. Let's try division, see if it works. 6 divided by 3 divided by 2, where I'm grouping the 6 divided by 3. Does that equal 6 divided by 3 divided by 2, when I'm grouping this 3 divided by 2? All right, 6 divided by 3 is 2. 2 divided by 2 is 1. 3 divided by 2 is 3 halves. 6 divided by 3 halves is going to be 4. So these are not equal. So that is no. All right. So in this next problem, consider the expression 7 minus 2 plus 4. Can we just write these numbers in any order? 7 minus 2 plus 4, 2 minus 7 plus 4. Can we just switch it like this? So this is problem 114. We have 7 minus 2 plus 4. Can we just switch the order to minus 7 plus 4? Just use the commutative property and change those. Okay, so we know that we're changing the order, but still this is subtraction and addition. Subtraction and addition. So we would go left to right, because order of operations says we use the left to right rule. So 7 minus 2 is 5. 5 plus 4 is 9. 2 minus 7 is negative 5. And negative 5 plus 4 is negative 1. So can we use any order? The answer is no. And the reason why we can't do it in any order is because we have subtraction here. So since we have subtraction, we know that we cannot use a commutative property with subtraction, right? So how can we solve this problem? Well, we remembered from a previous lesson that whenever we have subtraction, we can always write subtraction as an addition problem. So let's rewrite these as addition problems. So the first one, the 7 minus 2 plus 4, we can rewrite it as 7 plus negative 2 plus 4. So now we can change any order that we're doing these numbers, right? Now we can change the order. We would move the 2 to the front if we wanted to, but it is a negative 2, all right? So we're not just changing the order, we're changing the whole negative 2. So if I want to group the 7 and the 4 together, 7 and 4 is 11, and then 11 minus 2 is 9, right? So now I could change the order. I could change the negative 2 plus 7 plus 4. So instead of doing this, I'm moving the whole negative 2, so like that. So that would give me negative 2 plus 11. Or I can just do these first. Negative 2 and 7 is 5, and 5 plus 4 is 9, right? So this is 5 plus 4, which is 9. Or I can do 7 plus 4, which is 11, and 11 plus negative 2 is also 9. So both of these are equal to 9. Doesn't matter which order I do it, but as long as I change it to addition. So when everything is addition, we know that we can move things all around. Okay, so the next problem. So we have a couple of examples. So if I have 10 minus 2 plus 4, what would be beneficial to move these numbers around? What can I do? So think about it. We can rewrite this as 10 plus negative 2 plus 4, and that would give us 12. All right, so let's rewrite these. You have 3 minus 5 minus 2 plus 6. Let's go ahead and write them as addition. And we can see our answer will be 2. And then we rewrite these as addition, and we can see that our answer is 2. Okay, so a little bit more practice. So we have this student who's working on this problem. They have negative 4/3 times 1 2/5 times negative 3/4. So what they happen to do is take the negative 4/3 times 7/5. So they change the mixed number to 7/5. And so now all they have is fractions, so they're multiplying fractions. So the first thing they do is they multiply the 7/5 times the 3/4 to get 21 over 20. Okay, so 21 20ths. So now we have 4/3 times 21 20ths. Okay, these are the two numbers that they put together. All right, then what do they do? 4 times 21 is 84. 3 times 20 is 60. And since both of these numbers are negative, we know that we have a positive 84/60ths, right? So they changed 84/60th to 1 24/60th, change it to a mixed number, but we don't need to do that, okay? So what is another way we can do this that would kind of simplify this a little bit more? So here's the next example. Let's finish this problem, but using the concepts that we just learned about, who could think of an easier way that we can solve this other than doing 21 over 20ths and then multiplying the 4 times the 21? Okay, so one thing we can do is, since this is multiplication, and we know that multiplication is commutative, that we can change the order of these numbers. Now, what would benefit us if we change the order of these numbers? If we change negative 4/3 right next to negative 3/4, you would notice that those numbers are reciprocals of each other. And we all know that when we multiply reciprocals of each other, we get 1, right? That's 12 over 12. Negative times a negative is a positive. So this would give us the answer of 7/5, because the 3's cancel out and the 4's cancel out. They all become a 1, so that's -1 times -1, which is 1. All right, so that simplified that problem significantly. All right, so let's try a couple other examples. Let's do -9 times 1/9 times 3/8. So how can we solve that one? Okay, and the next problem, this is problem A. Let's do problem B. Let's do problem B over here. We have -5/12 times 3/7 times 4/9. So how would we work that one out?